That was excellent. Thank you very much for listening to that. We Phil actually mentioned micro gateways, and I think that's a fabulous segue into the next session. So we will have Hieu presenting, Hieu Nguyen Nhu. Hieu is a principal cloud native technical specialist with Microsoft. He has been helping customers deliver successful cloud native applications on Azure. So Hieu, take it away. Tell us all about the Microgateway Pattern.
Hi, T. Can you hear me?
Yes.
You're able. All right. That's awesome. Yeah. So during the course of my presentation, please pardon if I have a background noise. I have a drilling neighbor today, but hopefully it doesn't come through as much. Yeah. So my name is Hieu. I'm based out of Singapore, and I work with a lot of customers to develop their applications and essentially innovate them with Azure technologies. And so one of the key learnings and patterns that I'd like to discuss with you is how would you actually implement that in terms of having a enterprise that might span multiple countries, and how would you implement a pattern where individual applications team can actually be self-sufficient, independent, and might be able to expose their applications in a micro gateway pattern, right? So my agenda is, first of all, I will cover a bit about the concept of like open API. And historically, I've been talking about open API, open banking in previous API Days conferences in Hong Kong. So here, then covering that a little bit, and then we'll move on to how do you do automations for a enterprise that span multiple countries, and then how do you implement micro gateway patterns, and how do you actually implement further application services and support from some of our application framework to make the micro gateway pattern actually better. So yeah, going into it, then we'll say about what's an open API. So open API is, traditionally you would actually have API that is within your network, not published to the internet, and it's connecting a lot of your system together, and it's often sit behind a reverse proxy, layer 7, layer 4. So Open API is essentially available for you to expose publicly. It requires, API specific security layers, maybe a client certificate or OAuth2 or OpenID Connect JWT token. And it's essentially used to integrate with external partners, and it could be, something that generate revenue for your company. So essentially, Open API, triggers not only a specific industry, but it could actually span and be very specific to banking, very specific to health, and oil and gas, and many different companies that want to expose their system in a compliant manner. So essentially, we work with a lot of partners around the world to actually, implement a lot of these projects, not only in, North America, Europe, but also in Asia and Australia as well. So it's gaining a lot of tractions, and we have like multiple projects in Singapore itself, in Hong Kong, and in China and Japan and everywhere with our partners. But often, with these open API, then you have a lot of application team that are being worked on, and they need to actually expose it kind of centrally, and then maybe they will use a single tenant. They'll use a single tenant sort of deployment of API management, API gateway, or they'll have like a multi-tenant sort of deployment. So it definitely bring like new challenges. You need to be able to host it publicly while still controlling access. Need to be able to manage version. Need to be able to store data at scale. Need to be able to process update in near real time. And you essentially need to be able to post notifications to partners, eventing, and you need to actually make sure that it's all running reliably, right? So new challenges would actually require a new technology solution. So Microsoft essentially provide you with a lot of tooling and services that allows you to, not only controlling your API, you have a lot of options either to use like serverless or low code logic app or Kubernetes to host your API backend. And then you have like, a traffic manager or Azure front door CDN to actually provide a reverse proxy that is multi-region into those services, right? So now that's pretty much the high level of Open API, open banking, and then how Microsoft, have some of the tooling that will address those. So going into specific, customer use case, then let's actually talk about like, a customers where they have like a multiple tenants and multiple subscriptions that might, span a lot of countries. So we call those like, local business unit 1 and then local business unit 2. So that might be Singapore, Hong Kong, and then, Philippines or some other countries. And then for here, each of these countries, they have their own tenant and they have like, their own production in subscription and then non-production subscription and sandpit subscription. So essentially, for each of these tenant, then they will often have a production and a DR or primary site and a DR. So in this case, we might actually address them as a Southeast Asia and then an East Asia sort of deployment. And we would actually have some of the application being spanned on both sides, right? For DR purposes. So essentially, a lot of our API gateway as a central reverse proxy, that it would be deployed centrally for each of these LBU, and we would actually replicate that model into the remaining countries or LBU. And so essentially, you would actually have like the API management service that sits on layer 2 in terms of the landing zone, and then we have the application layers that is one layer above that. And then essentially, when you have a central API management service, what we need to do is essentially have an automated pipeline that will be able to read the application's API configurations that contains the Swagger and the policy for each of the API, for rate limiting or for maybe for monitoring and for JWT validations, like many of these things, right? So this model is actually working well. We have it in production with a number of our customers. We templatize it for each of the LBU so that they own a central multi-tenant API management service. So that is like the single ingress into each of those local business units applications. So the pipeline, it could actually, we would actually have like one pipeline for each of the applications. So when you have like, free applications like this, then potentially you would actually have an app reference to that particular applications. Where is the repo, like where we need to register. And so essentially these centralized API management service would actually run a trigger all the pipeline and then be able to retrieve all the policies and backend URL and the Swagger definition for the Open API definitions, right? So in that scenario, if you go into very specific, typical integrations, then you would actually have API management as the central proxy, and maybe you have an layer 7 web application firewall in front, like app gateway or Nginx or what have you. And essentially that will be the ingress, and then it will pass down to the backend app that might be Logic app, or might be Kubernetes or some other compute that you might host it. So here, what I want to show you is this is a typical pattern for a local business unit. It's easy to control, but in some scenario, where you might have like your application may deployed on another cloud, or on premise, or on your local machine even, then a lot of enterprises, they actually demand like, how can we have a gateway for each of the application independently? So that's what the industry actually calls the Microgateway Pattern. So it's essentially when you it's not only about like Azure and only experience anymore, but and have a central gateway, but you might have like a different subscription or different cloud, or even an on-premise data center, and that is essentially where you would actually deploy I can actually go here, where you would actually deploy maybe Docker Swarm or Kubernetes on-premise on the other cloud. And then we would be able to deploy a container that actually has the self-hosted gateway. And all of these self-hosted gateway, they can actually synchronize with the management plane here by this dotted line. So anything that you update on the management plane, you can actually specify, okay, I'm gonna publish the application A, and I want the application A. Let's say application A is I don't know, like Singapore API. Then I want to actually expose that to the Singapore self-hosted gateway, right? So only a subset of the APIs, which is the Singapore API, will be actually published to the Singapore local region. And essentially, we could now start to actually think about, okay, if we have like 10 applications, each of those applications are actually serving, having different API definitions, can we actually deploy like, 10 different gateway locations, and then start to have them be able to only control the set of API and, the only the gateway that they have deployed on their premises will be able to access those API, right? So now we start to have like, a real multi-tenant sort of a workflow where you're able to provide, independence, and able to allow, each of the applications team to innovate and have their own pipeline and their own, guardrails with other APIs, right? So here, as you can see, all of these self-hosted gateway will be serving traffic directly from the client. So the client will not need to go to, the central gateway on Azure anymore. They can go directly to those self-hosted gateway, and those self-hosted gateway could actually serve the traffic by forwarding that directly to the backend defined. Yeah, so there is a lot of, you have the API management gateway that is sitting on top. And then the backend could be anything. It could be from, any HTTP-based backend, like, functions, Logic app, or app service, or Kubernetes, or even like, HTTP backend on a VM or another cloud. And then some of the technology where we have also improved is to allow the integrations, of these applications backend to actually work together in an event-based manner, or have the messaging, capability to talk between the backends. Or nowadays, we are able to also, make use of our distributed application runtime framework and be able to have API management to talk to the backend applications via this, Dapr framework. So I go a bit deeper into what is Dapr, and then I'll try to explain, like, what is the value behind it, right? So as you see here, then we have Dapr, which is essentially a distributed application runtime that is able to provide, capabilities such as service invocations. And this is a capability where you have microservice A want to talk to microservice B. And we have like capabilities like state management, which allows a microservice to persist its state in, say, in a NoSQL or a SQL database or Redis. Or you can actually also use Dapr to actually templatize a publish and subscribe pattern. So essentially, if you want, like, your message from microservice A to actually publish it to the remaining microservices that they are subscribed to, then you can actually use Dapr to publish and publish those message. And then the publish and subscribe component could be backed by Kafka, or could be backed by Service Bus or Event Hub, or many different technologies. And essentially, we have also some resource binding in order to create a cron job, or we have like a virtual actors that allowed like a multi-threaded processing, and we have like distributed tracing with observability and integration to HashiCorp Vault or Azure Key Vault. So essentially, Dapr is available for many of the languages such as .NET, Java, Go, Node, or any of the languages as an SDK. Or for some of the languages that we might not have the SDK, then as long as you can communicate to Dapr via a local host or HTTP, then you are equipped to actually communicate to Dapr, right? So that's like a very high level of what Dapr is. And essentially, when we talk in the context of API management, then we'll look at, okay, so if we have like a API management, and then we are deploying that self-hosted gateway into a Kubernetes cluster, then this would actually allow a scenario whether you want this API gateway to, okay, it will actually receive traffic, and it can actually direct the backend straight to the user applications. But with Dapr, then essentially there will be sidecar in all of these parts. Then that will essentially unlock a scenario where you can use API management to talk to Dapr, and then Dapr would actually talk to the Dapr sidecar in the user applications, and then that will actually go through the traffic in this, Dapr service invocation network. So this would actually give you distributed tracing by default, access control by default, and also if you were to use API management to also talk to Cosmos, or talk to publish subscribe pattern, then essentially this is what Dapr is unlocking, right? You can now essentially, instead of talking to only one backend, you can do a publish and subscribe, or you can do a state store to Cosmos or storage account, and you can do like an output binding to Kafka. Like, you can do so many things with this Dapr enhancements for your gateway. So just a bit of a demonstration. Let me see how long I have. I have like 8 minutes. Okay. So a bit of a demo. Let me actually show you here. This is a demo that I did. So essentially, I'm from a global black belt team, and essentially, from our team, we have like this implementations of an example which is called Red Dog on AKS. So this is Red Dog is essentially simulating a scenario where you have like a coffee shop that you have a order service. So from the UI you can actually order a coffee, or you can have a cron job of the virtual customers that actually keep ordering a certain drinks, and then this would actually publish and propagate that order into a loyalty service to increase the loyalty points of that particular customer. It will actually triggers a receipt where it generate a receipt in a storage account. It will trigger a counting service to actually store those data into a SQL database, and then you actually triggers a Macline service. So there will be a virtual worker that actually monitoring the Macline service in order to actually make the drink, right? So this is a pattern where, can we enhance it with a micro gateway from API management? Then essentially, when you go to API management, let's say here, right? So essentially, you can actually make a gateway, and then you can use the configurations here to actually deploy that gateway into the Kubernetes clusters, just like I do here. So once you deploy it, then let me open up my code space. Where is my code space? Okay, my code space is here, as you can see. Then, as you can see, this is deployed, and then I have deployed also the API management, which is essentially here, in Dapr as well. So this is my API management gateway, right? Then I could actually use the API management to import the Swagger that I have from those microservices. So if I were to go to, give me a moment. If I were to go to outside of the gateway, go to API, then you see I have imported the accounting service, the Macline service, and then the order service, right? So within the order service here, let me actually close some of these. Okay, within the order service here, then within the Macline service, let's say, for example, then I would actually have a backend service. Let me see how I can actually zoom this out. So this would actually allows the self-hosted gateway in order to talk to the Macline service under orders slash and then the name of the store, right? So to make this a bit more straightforward, then if I were to uh, curl the orders directly here, the Macline test path, right? So this is the Macline service, and then this is the output that the Macline order for the store named Denver actually gives me, right? So instead, I don't want to actually call this directly because I wanted to call it via Dapr. So instead of doing that, then I will actually retrieve the IP of the self-hosted gateway. So that is essentially here. So as you see, red.aks, it would actually have like the gateway as well as oh, sorry. There you go. Logs. And then it would actually have this self-hosted gateway, right? So these are all the traces of the self-hosted gateways. So what I do here is I will actually try to, let's see, okay, exactly. PO. Exec PO dash IT dash SH, right? Oops. Okay, so I think I'm inside, and then I'll open up this. There is a curl. So there is a curl, as you can see. So this is actually provided by Dapr. So you see, Dapr is available in a local host and on port, 3500. And then I'm calling the make line service, and the method is order Denver. So this is exactly what API management is calling behind the back whenever I'm using this policy to actually call the make line service order API, right? So I'm just providing the parameter that is Denver, and then it will actually provide it, the result for me. So why I need to actually call via Dapr instead of actually calling direct? Because going via Dapr, then I would actually have all these nice out-of-the-box features where I'm able to see, where I'm able to see all of this flow distributed tracing with Zipkin, and I can actually use the PubSub pattern, and then I can actually use many other services within it as well, as you can see. So you can actually trace what are the virtual customers are calling to the make line, and then you can actually do further tracing and exception tracing on top of that as well. And last but not least, I want to say, whenever you have a individual team actually working on this on their own API, then you can actually create a custom role so that they only have access to change their microservices. So let's say here, then if you were to have a make line service team work on this common gateway, then you can actually create a custom role that only allow them to modify their current gateway. And by doing that, then once you onboard an API, you can actually create more gateway. So let's say I'm the make line team. I only have access to actually see and modify this operation. I can also actually assign this gateway to assign this API to a certain gateway. So let's say I have a Red Dog AKS gateway here. But if I want my particular micro gateway, then I just go here, and then I just create, and I'll say, name make line. And then the location is maybe Singapore. I'll just create that. I'll add an API, probably add after. So here, then I'll just go back to the API management here, and then I'll just associate that to the make line. Yeah.
Hieu, we have unfortunately run out of time.
Okay. Yeah. Oh, good. Yeah, I just wanted to show particular this piece where you're able to go here and then select the make line and delete everything else, right? And that would be your own micro gateway. Yeah. Okay. Thank you.
Fabulous. Thank you very much.
Yeah.
Hey, I think this would have been incredibly helpful when I was at DBS and we were trying to kind of cobble this together by hand and using policies that we were scripting up and so forth. So this is super exciting. You mentioned this is just running on Dapr and obviously that it's an Azure API gateway. Have you seen this run across hybrid cloud, like whether it's other public clouds or even data centers and so forth?
Yeah.
How does that work? Well or not?
Yeah, I mean it's the goal, right? Like essentially Dapr, you can install it on any Kubernetes clusters or even Docker. And with API management, self-hosted gateway, you can also deploy it anywhere that can host it as a container. So with this arrangement, then that's exactly what we do with a number of our customers, where their footprint is not only on Azure but on other environments as well. So that's why, like, we would actually be able to centralize all of the operations and management on API management, and in the back is essentially just Dapr everywhere. Then you would be able to target non-Azure environments as well. Yeah.
Yeah, fabulous. Okay, wonderful. Thank you so much. And also, I think you're the first person to pop up a Kube CLI prompt. So congratulations
All
on
right.
that.
Thank you. Yeah, thank you.
Thanks, you.